Good morning, everybody. I think we'll get started. John Holland, Chief Development Officer of Pinchin here, calling in from Vancouver. This is the first of our 2023 Practice Innovation Series on building environmental technology solutions. Some of you may remember this series started at the beginning of COVID as a means of Pinchin sharing our lessons through the COVID period on public health and awareness and management of COVID issues in buildings with our community. And we've continued that since COVID, or the back end of COVID, to share lessons we're learning as we evolve our practice through the post-COVID period. Many of you likely know this, we all know this because we all use technology. Many more sensor-based and AI-based systems are being used to monitor many things we do, and the indoor environment and buildings are no exception. There have been many systems developed to support intelligent infrastructure in building operations and maintenance. And as we go through this, there are more algorithms being created to help us make better decisions in the building environment. And this webinar today is about the lessons we've learned in helping to develop some of those technology solutions, apply them, how we use the data, and how the data is beneficial in the future to ourselves, our clients, our community, and society as large as we navigate the next many years of this new evolution. So as part of that, I'd like to introduce our two speakers today. Our first speaker is David Shearer. Dave is the Director of Integrated Digital Services at Pinchin, and he was previously the National Practice Leader of Pinchin West. He's worked on many specialist projects around the indoor environment, notably around national disasters, including the Bow River floods, Slave Lake fires, Okanagan Valley fires, and Fort McMurray fires, giving solutions to how to reoccupy and manage the damage caused by those buildings from a tech perspective. He's engaged in emerging issues around gathering data, data visualizations, around all our professional work at Pinchin. And our second speaker is Mr. Ryan Hickey. Ryan Hickey has 20 years of leadership experience in telecommunications, including 15 years in a senior engineering role at BlackBerry. While at BlackBerry, Ryan oversaw the development of low-cost and highly reliable wireless technology for the company's smartphone devices. Ryan has several wireless and embedded system patents to his name and is currently a LoRAWAN ambassador for the LoRa Alliance, the method we use for gathering much of this data. He received his bachelor engineering degree in electrical and electronics engineering from Dalhousie University, and he's a PEng in Ontario. In lieu of a fee for today's presentation, Ryan has kindly made a donation to the Waterloo Region Food Bank. So thank you, Ryan, for that, and thank you for being part of our presentation today. There is a Q&A as part of the presentation, and a chat, Q&A for technical issues, and chat for questions you have regarding the content that we'll try and answer as we go through the presentation, and more likely at the end of each speaker's sessions. So with that, I'd like to hand over the mic to Dave, and look forward to today's presentation. And thank you all for being part of this session.
Thank you, John. Good morning and good afternoon, everyone. Thank you for joining us. I've worked at Pinchin for 20 years, and over the last 3 to 5 years, I've been focused on finding ways for us to do our work more efficiently using technology, and find ways to bring shed light on data so that our clients can better understand their portfolios of buildings. I think we've come to recognize that the PDF reports that we've traditionally issued to clients, they have value, but finding ways to interact with the data that's in those reports in a manner that's interactive and real time offers real benefits. So I'm really excited today to share some of our experiences at that. And we wouldn't be where we're at today without our collaboration with 11X, and Ryan has joined us to share some of their experiences as well.
Yeah, thanks, Dave. First, just let me echo my appreciation for everyone taking time today to join this, and also to Pinchin and Dave for inviting me to speak. I really appreciate that. I've really enjoyed working with you guys over the years, and this is exciting stuff. So my background for the last 20 plus years has been really about connecting things, whether it be a smartphone or IoT devices, sensor networks, And since starting 11X about 9 years ago, we've deployed all kinds of different IoT solutions, whether it be smart parking, which I'll talk about later, with some smart water monitoring, but also smart ag and a whole bunch of other different applications. So I'm really here today to kind of zoom out from the building space and kind of look at the sensor networks and how sensors are helping solve all kinds of problems in our society, and hopefully people can get something out of that.
Awesome. Thanks, Ryan. So going on about 4 years ago, Pynchon teamed up with 11X. We signed a joint marketing agreement. And in the early days of us trying to identify technology that we could use for Internet of Things, we explored Wi-Fi technology, some other LPWAN solutions, and then we stumbled across 11X and their LoRAWAN technology, which we immediately found quite compelling. While Pynchon are experts in environment and engineering, we're certainly not experts in wireless networks. And in order to get these types of initiatives up the ground, we partnered with 11X and their deep subject matter expertise in wireless technology, and really just the strong collaboration capabilities of their team have led us to these solutions that we're going to talk about today.
Yeah, and just to emphasize, kind of Pynchon, they are the experts in what they do, and they're the best in Canada, and we really want to partner with them. Our strength is the wireless technology and the networking and the sensors. So we provide that kind of base technology layer, bringing in our experience from all different types of deployments to make that a super solid foundation for the data that's going to flow up into the area where Pynchon lives, in the science and how to solve problems with buildings.
So just a quick agenda of what we're here to accomplish today and what we're hoping to share. We've gone through the introductions. We're going to talk a little bit about how sensors can change the way that we look at challenges. I think these examples are hopefully compelling. Why is right now the right time to consider sensor-based technology? In the last 3 to 5 years, this space has grown enormously, and the level of reliability that now exists with these sensors and the relatively low cost, I think we're in the golden age of sensors. What is LoRaWAN network and sensor technology? Talking a little bit about this. I think many of us on the call will be familiar with Wi-Fi and Bluetooth and technologies like that, but LoRaWAN is something different, and I think it's beneficial to understand that. We're going to present some sensor use cases, how 11X and Pynchon have been deploying sensors to kind of help support decision making and managing different environmental and challenges. I'm going to show a little bit about data management and dashboards, the product that we've developed internally, Pynchon Core. And share some project data stories just to kind of share how our clients have benefited from using this technology and where we see some really valuable use cases. And then we'll wrap things up with a Q&A. So over to you, Ryan, to give a bit of a primer on sensors.
Yeah, thanks, Dave. Yeah, there's some really exciting stuff coming up with those data stories. So stay tuned for that. It's going to be good. But for now, we're just going to take a step back for a sec. We're going to think about, okay, Dave mentioned that, this is kind of the era of sensors, and it's true. But why is that? And there's really been a lot of things that have developed pretty rapidly over the last 10, 15 years to kind of all coincide to make this a special time for sensors. So, the sensors themselves are pretty remarkable in terms of what they can do. And I'll go a little bit deeper on the next slide into an example sensor to give you an idea of the technology that's gone in there. This allows those sensors to capture some really amazing high quality data. But the data just sitting on a sensor is one thing. You really need to be able to connect to that sensor. And once that sensor is connected to the internet, that data can go to the cloud. So connectivity is another key piece. And Wi-Fi is pretty much everywhere now. We've got 5G, we got Bluetooth, and of course we have LoRaWAN that are all helping connect things that previously weren't connected. And all that data is coming in, and it's an enormous amount of data. So how do you store it, and how do you process it? it's really through innovations with cloud storage. It's very accessible and affordable now to dump loads of data into the cloud. And then once it's in the cloud, we're able to analyze it also in the cloud with cloud processing, which has come a long way. 15 years ago, it was a very small part of Amazon's business. Now it's their biggest part. All the big players like Microsoft are in there investing in this. So why is that important when we're talking about sensors? Well, the data by itself is not that useful. But once you get machine learning and AI and visualizations and alerts working for you in the software, now you're able to make better decisions. And those decisions can really drive the desired outcomes that you're after. And that's really through all of our customers that we've had in all the various markets and everything. That is the one thing that's consistent across all the successful projects. And that's being able to relate that data you're getting from the sensor. How is that going to help you achieve your desired outcome? So that could be productivity, it could be sustainability, it could be NOI or property value, it could be the client experience. It can be many different things that can drive the adoption of sensors. Next slide, please, Dave. So we're going to dive a little bit deeper into a type 1 sensor here. So one of the things that 11X does is we do smart parking. We design and manufacture our own parking sensor. So I'm quite knowledgeable with this sensor. So I thought it'd be a good one to dive into. And you can see here, it's the size relative to a pen. And inside this sensor, there's an incredible amount of technology. There's 2 microcontrollers, microprocessors. There's LoRaWAN connectivity, Bluetooth connectivity, 2 types of sensing technologies that we use to detect vehicles. One's a magnetometer. The other one is a 60 gigahertz radar. We have a battery that can last 10 years in there, and everything works under quite a wide environmental condition. And this is all for less than $100. Even 5 years ago, this was unimaginable. 10 years ago, this is science fiction. So a lot has come together in the technology space to really help you realize these types of sensors. And some of the sensors that Dave will go into later are similar in terms of the measurements they're able to take and the size and price, cost, I guess. Next slide, please. So we'll go a little bit deeper now into some of the wireless technology. Again, we're probably familiar with Bluetooth. It's pretty short range. It's good for if you're close to your phone, if you want to use a headset, and it's good for transferring audio. But it's not very good for video. It actually can't be used for video. That's kind of where Wi-Fi comes in. So Wi-Fi is great for streaming YouTube videos and all kinds of high bandwidth applications, but it's also short range. Once you leave your home, you're not going to be able to connect to your Wi-Fi network, for example. Luckily, we have 5G, and it's also very high bandwidth, very low latency. If someone gives you a call, you're going to get notified pretty quickly. That's what I mean by low latency. But it's also long range because this is deployed on towers and it's all throughout our environment, and it's pretty much ubiquitous in terms of being able to connect to it. And then there's this kind of space down the bottom right quadrant of the plot where LoRaWAN sits, and it's specifically designed for long range. That's where the LoRa comes from. And it's also designed for very small amount, like small kind of amount of data. So like a temperature reading or some other type of reading is almost perfect, where you're just sending a few bytes of data up pretty infrequently. Like by infrequently compared to 5G or Wi-Fi, I just mean like once every 15 minutes or an hour or a couple hours, something like that. And it's also built for low battery consumption. So if you think about 5G, I mean, it's really fast, it's really good, but of course it drains your battery every day. So again, LoRaWAN's really purpose built for these sensor networks. And we can get up to 10 kilometers outdoors, but that long range attribute is also very valuable in a building environment because you don't have to deploy as many gateways as say you would for Wi-Fi, which is shorter range. So it allows you to have a lower cost deployment. Okay, next slide, Dave. Just one last thing about LoRaWAN. Back about 8 years ago when we adopted LoRaWAN, there was a lot of competing technologies, and we chose LoRaWAN because of the LoRa Alliance. So LoRaWAN is the standard. It's what everyone designs to so that all the devices and gateways and everything can be interoperable. The LoRa Alliance is what kind of governs that open standard and really promotes it and gets membership. There's over 400 members. All the big companies are members of LoRaWAN. And that membership and the openness is what created this environment to have a very vibrant and prospering ecosystem. So lots of device makers to choose from, lots of gateway providers, solution providers, and everything's interoperable and works together. Next slide, please. So I'm going to talk now in the next few slides about some of the problems that we've solved with sensors. Some of them apply to buildings, some of them apply to smart cities and other applications. But it's really to get across that concept of, connecting the dots between, a sensor and, an outcome and value to the client. So, in this case, I mentioned the parking sensor that we developed. So we use that to provide all kinds of visibility into parking assets. So if you think about, a parking lot, the owner of the parking lot at any given time probably doesn't know a lot about what's happening in the parking lot in terms of how many cars are parked, how long cars have parked there, if they paid or not paid. All these things are kind of manual eyeballing of things and things like that today. So once you put sensors into the parking spot and you can tell if a car is there or not, it provides all kinds of value downstream. So in this case, the sensor communicates with the LoRaWAN network. The LoRaWAN network communicates with the cloud, and then that information can be distributed to an analytics dashboard or a smartphone guidance app to help get people to the vacant spots, or digital signage which can help guide people. And these connectors are what can really help drive desired outcomes. Next slide, please, Dave. And in this case, we have an example of Oakville. We've deployed 1,200 sensors in downtown Oakville and parking spots. And we're able to help them realize their desired outcome, which was to reduce traffic congestion. So Lakeshore Road, if you've ever been there, can be quite congested and quite busy. And this has an impact on greenhouse gas emissions and safety and just general frustration. So being able to help guide people to vacant spots was really a big driver here. So we put a digital sign in a couple locations to help direct people to open spots. Next slide, please. Here's another example of water metering. So sub-metering in buildings is something people may be able to relate to on this call. We have done some sub-metering for commercial strip malls where you have different clients consuming different amounts of water, and maybe you want to bill them differently because of that. But our biggest client base is municipalities who want to do residential and commercial water metering on a pretty mass scale. So their motivation is really to improve efficiencies and to provide more value. So instead of having someone walk around and read the meters, you can collect the meter consumption data on a periodic basis, hourly or whatever. And now it can automatically be integrated into the billing system. So there's all kinds of improvements, efficiencies gained there, as well as reduced errors because there's no manual entry, and then also provides transparency and visibility to the consumer. And often once they see what their consumption is and what time of day and all that stuff, they will actually reduce their water consumption, which is also a major outcome that they're looking for here. As well as once you have that real-time data, you can send alerts to like when there's anomalies happening like leaks. Next slide, please. So we've done quite a bit of water monitoring, whether it be river level or stormwater monitoring. And here's an example of groundwater monitoring. So in the region of Waterloo, it's quite a big region, and all of our drinking water here, I'm from Waterloo, I should have mentioned that. All of our drinking water comes from the ground. So there's these aquifers under the ground that store the water, and the region has to monitor them to make sure that they're managing their water correctly so we don't run out of drinking water. So they've done this by putting over 500 wells across the region. here's a picture of the wells there with one of our devices on there. So what the project was is to essentially replace, I think it was semi-annually manual reading with every hour reading. And that helped with safety because some of these sites are actually in remote locations and can be a safety issue. They get alerted as soon as there's a problem, so they're not going to lose 6 months of data. And basically that data gets automatically entered into their downstream analytics software. So that also improves efficiency. Overall, it's a much lower cost, but much higher quality system. And I think that might be it for me.
Thanks, Ryan.
All right.
So I'm next going to talk about how we've been able to deploy 11x's sensors on our projects. 11x is responsible for helping us pick sensors, identify reliable devices, the wireless connectivity through their gateways, and their network operations center. And then at the far right of this figure, you've got Pynchon Core, which is our data and analytics platform. So we're able to feed data from just about any sensor into Pynchon Core, and then provide notifications and alerts and add kind of interactive value to that data. With respect to the indoor air quality work that we've been doing at Pynchon, kind of looking at legacy and future. At top here, you can see a device that we frequently use to do spot measurements in buildings. So if you were a proactive kind of building owner and manager, you might have indoor air quality spot checks done on an annual or quarterly basis. And our field technologists would come into your building, walk around with this machine and take kind of representative samples and jot them down on paper. Bring that back to the office, collate all the data, identify any anomalies, and write up a report stating what had been observed and any recommendations for improvements to site conditions to benefit indoor air quality. So some of the limitations of this was that if you did it quarterly, that you still were missing kind of the other 361 days of the year. So you might miss conditions that exist that happen sporadically, and it's just a limited snapshot of data. Kind of now we're looking at deploying real-time sensors in buildings, collecting measurements continuously. I like to think this as you now have an indoor air quality expert in your building 24/7, 365. If there are sporadic events that occur that result in conditions that contribute to occupant discomfort or concern, then they're identified in real time, notifications sent to the building management staff, and you can really kind of get a handle on the overall conditions of the building and determine maybe when it might be necessary to kind of conduct a follow-up IAQ investigation and actually get boots on the ground to figure out what is causing the problem. So this is a fundamental switch, but it is the future of indoor air quality work. Here's kind of a quick diagram to show what kind of the network setup looks like. Here's kind of a building where we had deployed little LSIS IQ devices. So they measure temperature, relative humidity, and carbon dioxide. And then those devices that are taped or attached to walls using double-sided tape relay their data back to a gateway. And I can't emphasize enough the convenience of this networking configuration. So the gateways operate on essentially the cell network. Each one of them has a SIM card in it, just like your cell phone. So this technology allows us to bring our own network into client buildings. And what that means is that we don't have to connect into the local IT infrastructure. And as a result, the cybersecurity issues that might exist with that are alleviated. And 11x has kind of taken care of network security as well as to Pynchon. You see these little locks on here. We've completed a number of kind of cyber audits or completed cyber questionnaires for clients and they've always been quite satisfied with this configuration. So the network propagation of LoRaWAN technology is phenomenal. It goes through concrete. I think the first time I installed a gateway, I was amazed that one LoRaWAN gateway could cover an entire building. Whereas if you were deploying Wi-Fi technology to achieve this, you'd probably look at installing 5 times as many gateways in order to achieve the same network coverage. So really good for new construction and especially retrofit applications where you might have previously been looking at a complex wiring project in order to get sensors like this deployed. This is Pinch & Core, which I could talk about for an entire hour in and of itself. So if anyone on the call is interested in a demo, I'd happy to provide that. But essentially, this is where all the data from the sensors funnels in. There's different kind of analytics that you can run on it, comparing different locations, buildings, the entire portfolio. We've really designed it so that it can be valuable to everyone on the property team. So if you're responsible for a portfolio of 100 buildings, you can quickly log in and see where challenges might exist. If you're responsible for a particular building, you can zoom in to that level and see just that. Notifications, I think, has been one of the features that our clients appreciate the most. So this is emails and text messages that can be driven out of the system when certain conditions exist. We have leak sensors that can be deployed. Knowing that a leak has occurred and addressing it quickly can have a massive benefit of limiting the amount of damage that could occur. We have floor plans. So essentially you're zooming into the exact location in the building where that sensor exists. So without even kind of getting up off your chair, you know where the problem exists in the building. Gateway management, essentially understanding the network functionality. We've got really good uptime with this, so it's not used very often. And then reporting. So we're able to design custom reports for clients. So what that means is that rather than you getting a quarterly indoor air quality report, you can get one that's automatically generated and kind of rolled up on a weekly or monthly basis for one building for a portfolio of buildings. So that the building management team can be kept aware of what's going on. So the report has the same look and feel of our traditional indoor air quality reports, but it's completely created inside the software. I did want to touch a little bit on some of the unique and interesting sensors that we've encountered through working through this. We've pretty much tested every IAQ LoRaWAN sensor that's out there. Some of them are low cost and really easy to work with. They have maybe fewer sensors on board them, so fewer parameters, and are battery powered. And then there are some units that are more expensive, carry more parameters, and need to be plugged into the wall. So we might deploy more kind of these the lower cost ones and fewer of the kind of more expensive fully featured ones. But to get a whole rounded view of the conditions in the building, a reasonable strategy would include both. So this sensor here is IAQ, this sensor here is IAQ, and this sensor here is IAQ. This sensor with NetBox written on it in green is a leak detector. So these are helpful to deploy in areas that are water damage prone, janitorial closets, washrooms, lower levels of buildings, in around any sumps, that kind of thing. But these are really beneficial to get immediate notifications. This is the parking sensor that Ryan spoke to earlier. This one I've included just because I think it's interesting, but I guess the classic question, how do you build a better mousetrap? Well, the answer to that within the LoRaWAN realm is to get a notification when it catches a mouse. So I think that's pretty neat and novel and gives you an idea of the type of innovation that's going on in the space. This is a motion detector or occupancy detector, and these can be used to kind of analyze occupancy patterns in buildings. Very helpful when you're looking at carbon dioxide concentrations as well. This device here, which you would have seen in the photos of Ryan's examples around groundwater monitoring, is 11X's XIU. And this is a really cool tool because it's a bit of a Swiss Army knife of a device. We've been able to connect this to some of our legacy indoor air quality sensors and bring that data in, which is really neat. This mini Q device is used in waste and recycling bins to basically determine whether or not they're full or empty. So in the example of a building where you have building maintenance staff going around and emptying recycling and waste bins, they can focus on the ones that are full rather than focusing on all of them, and that adds efficiency to that routine and task. And then this is a door and window sensor, which we found helpful kind of in monitoring conditions where maybe there's a critical entry point or a critical airflow pattern that needs to be established for a door being opened or closed, and understanding the occupant behavior around that. I do notice that I have a question in the Q&A from Faye Graves. Can the LoRaWAN ecosystem connect to a BAS system? Great question. So Faye, we have been working on that use case with 11X. And I think we've demonstrated through technology they have that you can, there is a BAS LoRaWAN integration. So it is possible to get LoRaWAN sensors to show up as BAS objects. And I think the technology that we're working with on that is BACnet.
Right.
Next slide. Key growth drivers for building sensors. So we saw a huge level of interest around COVID and return to work. I think if there's any takeaway from me as an indoor air quality professional post-COVID, is that people are now awake to the fact that healthy indoor environments matter. That adequate ventilation matters, that filtration is important, that keeping occupancy rates reasonable is important. So I think this new view of indoor environments is important. The thing I always like to say is, considering we spend 90% of our time indoors, why do we spend so much time talking about the weather? These sensors, this data gives us as much insights into the indoor environment as we have into the weather. And I think having visibility to that is going to be important to building occupants. So as well, building optimization, a lot can happen in an air delivery system between the air diffuser and the occupant breathing the air. And these sensors really allow you to kind of figure out what the occupant experience is going to be like, what's the temperature at a desk, or what's the temperature at a particular zone in a building. Cost control, figuring out the timing of HVAC start and shut off times based on occupancy, and really focusing on driving benefits through building optimization. Sustainable building, we're seeing lots of building performance standards that are now including a building sensor component. So they're looking at real-time data being captured in a secure data portal, and then being submitted up to these organizations at quarterly or annual increments. So this is big. LEED, WELL, BOMA BEST, RESET. I think this is going to evolve substantially in the next few years, and really become part of a building ESG strategy. Climate change has definitely been driving some events that have made this technology important. Extreme weather over the last few years, extreme temperature events in British Columbia, Ontario, all over the place, have driven the need to understand what thermal comfort in building is, specifically in long-term care facilities, anywhere that there are sensitive populations when it gets really hot. Unfortunately, certain individuals can be really negatively impacted by that. Wildfire smoke, something that I've had lots of experience with in the last handful of years, living in the Okanagan in Kelowna. We're subject to wildfire smoke substantially. So looking at ways to evaluate how that's impacting the indoor environment. and putting strategies together to mitigate. Ambient air pollution being another one. So I'm now going to dive into some data stories and share basically some snapshots of data and site conditions that occurred to kind of provide a bit of a story on how active IQ and these sensors were beneficial to our clients. So this is a graph at the bottom of carbon dioxide concentrations in our Ottawa office in around March 2020. And what this is a representation of each little kind of peak that you see there is a Monday to Friday. So kind of leading up to the COVID shutdown, you can see our normal occupancy pattern with CO2 kind of peaking up around 1,200 each day. And then the dreaded day on around March 14th, where everyone got sent home to work from home. And then you can see the carbon dioxide concentrations drop off substantially. So this would be a rare opportunity to actually see in real-time graphing what occupancy trends and carbon dioxide looks like. And we saw this time and time again through all of our sensors that were deployed at that time. So this relationship is important to understand and manage for healthy environments. Next up, we have a school board where we're engaged to kind of look at carbon dioxide concentrations in a couple of different types of buildings, kind of newer, more modern schools that were mechanically ventilated, and older schools that just had natural ventilation to look at carbon dioxide concentration. So you can see in that top graph, kind of carbon dioxide peaking out around 800 ppm, which is great. And then on the lower graph, carbon dioxide frequently peaking up above 2,500 ppm. So I don't think this is intuitive to anyone who understands these types of buildings, but it helped the school board to identify classrooms that maybe they should be occupying less and relying more on mechanically ventilated spaces. So help them in understanding and decision making. There's another question which I will grab here. Oh, just Faye responding back. Thank you. No worries. Wildfire smoke. So this is that photo there was taken a few kilometers from where I live. This has become a substantial event as we have hotter, drier summers. The graph on the bottom is a representation of PM 2.5. So that's the kind of particle size that's closest to wildfire smoke. And then offices from Calgary through Victoria. These are the sensors that we deployed in our own spaces in typical commercial buildings. PM 2.5 normally is below 16 micrograms. This bright green kind of bulge in the middle is our Kelowna office, where airborne particulate inside was peaking at 300 micrograms per meter cube. So this is just shows how much an impact that you can have indoors because of outdoor conditions. And through working with a number of clients on this, we now have designed indoor air quality management plans, different types of strategies, including upgraded filtration, monitoring through the wildfire season, which is typically from June kind of through to mid to late September. And then having strategies that they can deploy rapidly to put air cleaners in place, increase ventilation rates, shut down outdoor air recirculation, that kind of thing. So we will see more of this in the future. Another use case that we've found to be quite beneficial is doing dust monitoring around construction, and specifically in the healthcare environment. From those of you that aren't familiar with this type of work, essentially construction projects can, if the dust from them isn't contained in hospitals and long-term care facilities, it can make immune compromised individuals very sick. So it's important that good dust containment is used around that. This is literally a life and death scenario in this types of spaces. Here's an example of kind of airborne particulate PM10, the type of dust that you typically see related to construction projects, drywall dust, that kind of thing, peaking at 70 micrograms per meter cubed right at the start of a project. So from this, we were able to a notification was immediately driven out to the infection control practitioner, the contractor responsible for the work, and Pynchon, and then very quickly to find a resolution. I think in this case there was a piece of upper seal that had not been properly installed or wasn't fully effective, and then subsequently after that, for the next 3 days, you can see that you're at or around normal concentration. So this is the kind of thing that we've always wanted to be able to do, but couldn't until you had this technology. And in the past, maybe there would be a complaint that there was some visible representation of dust in the hospital. We'd go take a look at it maybe 12 to 24 hours later, have a meeting, talk with the contractor, and maybe within a couple of days, we'd have a solution. Whereas this real-time visibility really drives results and a higher degree of compliance. And we're finding that the hospitals and the contractors we're working with really appreciate this. They want to be doing this work well, but without having visibility to this, it's hard to understand the dynamic of airflow and dust in a building. So when these events occurred, they were able to log into Pynchon Core after getting a notification, and then look at the floor plan and actually see which sensor had registered the exceedance. And so again, without really having to get up off your chair, you know what's going on, where it's going on, and can begin to piece together a strategy to fix things. So this is really incredibly powerful. I think thank you all for joining today. I did want to touch on closing, where we're coming from with this and our partnership with 11X. We are both passionate experts in our respective fields, collaborating on finding technology that suits the work that Pynchon is typically delivered, and support from 11X has been phenomenal. We really see a lot of value in this delivery model. Getting real-time data is phenomenal. Our staff spending less time in front of a windshield and more time providing value to our clients through insights and real consulting is of incredible value. And it's just been really fun to see the range of solutions that we've been able to identify and provide. And I might have told stories about 5 or 6 things, but there's probably 100 more that we can work with clients to develop, and really look forward to that collaborative innovation. I think it's a really exciting time. Ryan, did you have any closing words before we go to Q&A?
No, just did a great job there, Dave. And yeah, thanks so much for having me, and thank you everyone for your time.
Just thank you both. Great presentation. A couple of questions or insights I took away from this. One, clearly this is a journey. We've gone from sampling with people and monitors to remote sensing. This is going to evolve. There's going to be more data, more analytics, more refined tools, and better management. So I think the lesson for people I took from this is that stay tuned to the story, because this will be different in 12 months' time. It'll be different in 5 years' time. That's my observation. Secondly, better diligence ultimately, and I have this on a very personal level with a fire alarm and a smoke alarm and a water alarm in my house, will ultimately lead to better insurance results. So bear that in mind, that the risk management industry is all about reducing claims, and this is part of reducing claims, part of your story. And I guess lastly, as part of ESG commitments, the more you do with data, the less you do with travel, you get a better car. Ultimately, we'll have a more beneficial carbon footprint and better GHG reporting. So for organizations contemplating this is very much part of that journey. Do those points ring true with you, Dave or Ryan?
Absolutely. I think the wireless technology is just at a position now where it's competitive with sending people to do the same thing. with the richness of that real-time support. So I think the time is right.
Yeah, and I think to your point, there'll be a lot more finely grained resolution of the measurements. So maybe you have some sensors here and there already in your building, but now you can add some more because it's cost effective to do so, and it's bringing you more insight and more value. So, and then there's the constantly evolving AI and other software that's helping monitor things now, but soon we're going to go to like more actionable things that will be handled by AI in the near future. So that's going to be exciting to see.
Absolutely. I remember when I first kind of started talking with our lead developer for Pinchin Core, Love Chowdhury, about machine learning and AI. And I was like, well, Love, how many sensor points do we need to start doing this? He said, oh, about 10,000. I was like, okay, well, we're approaching 1 million now. So it really is just a treasure trove of data that we can start deploying some of these exciting new technologies on, and driving insights where maybe they weren't there before, or maybe the way that our human brains kind of think about it aren't as effective as these new emerging capabilities.
We have a question from Alan McDonald. How does the water sensor communicate a leak like a running toilet at a remote property? Cell phone, Wi-Fi, GSM, etc. Sure.
I can get into that in detail. So the leak sensors are essentially it's a processor and network head, and then a couple of wire leads that run to a sensors with 2 little pins on the bottom. When the water reaches the point where it makes contact with those 2 pins, it essentially recognizes a signal that then communicates back over. There's a couple different priority configurations in the way that data flows in LoRaWAN. One of them is that it just keeps reporting at certain intervals. For leak sensors, it goes at high priority, so that when the leak occurs, the notification gets sent and essentially bounces to the gateway. The gateway bounces that up to the cloud, and then that comes back into Pinchin Core, where an SMS system kind of relays it. And we've tested the response time of this, and it's less than a minute typically for that to occur. So it kind of bounces up to the cloud and then comes back down to your mobile device. Does that answer your question, Alan?
I could add one thing.
Go ahead, Brian. Yeah.
Oh, it does answer. Okay. I was just going to say, because the leak sensor that Dave described requires water to be on the floor to short those leads. If you just have a running toilet, it may not actually overflow. So in that case, that's an interesting one, because that's where the machine learning algorithms can come into play. If you have water metering happening, and you have a certain level of baseline consumption overnight, say, and now all of a sudden that baseline consumption is higher, that machine learning algorithms can detect the anomaly and send an alert based on that.
Thank you, Ryan. That's a better answer.
Yeah. Oh, I think that
to the leaking toilet scenario.
That kind of opens up one more thing, doesn't it? When you look at this data, as I've looked at the day-to-day during the forest fire season of our internal IEQ sensors, you become quite addicted to this. You learn about it, you understand it, you analyze it, and it deflects your attention rightly to do things, to respond to data. So be aware, when you open up this Pandora's box of more data, which is usually beneficial, it changes your job. It changes your interest in how you manage things, and it makes you much more invested in how that building operates, because you just know much more. So that's got to be a good thing.
John, I'm so glad to hear that I got you addicted to Pinchin Core.
There you go. That's good. That's my that was my lesson. That was my lesson. Okay, well, I think that was just a great presentation. Good feedback from our audience. I'd just like to close by thanking our speakers for putting this together, for being part of our journey. To Kaylee and Rui in the background for putting the presentation together so it goes seamlessly. And to our audience for participating, listening, and asking questions, and helping us be better at this so we can be better for you. So with that, I will wish you all a good day, and stay tuned for further presentations as we continue this journey. Thanks, everybody. Have a good day.
Thank
Thanks,
you.
everybody.